These examples go with lesson 6.6 or lesson 6.5 in the second edition, Assessing Normality. Example 1. For each of the following dot plots, determine whether it is reasonable to treat the sample as coming from an approximately normal population. Let's look at A. If we think about the sketch of what a normal curve would look like, and it should look kind of like this right here if our data were normal. And what we actually have here, which is something that we start here and then we kind of go down, 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 and then we come up and then we go back down again. This does not look like a normal curve. We've got two places right here where we got two little hills, I guess we could say, two modes, if you will. And so this one, no, we're not going to treat this as coming from an approximately normal population. Now, when we look at graph B, again, we're going to imagine our normal curve sketched in over top of this like so. And when we see what we have, we're low, we're coming up. We did have kind of a dip here, and then we went up and came back down again. This is fairly reasonable right here to treat as a normal curve. I know we've got a little bit of a dip here, but you'll notice we've got this big wide gap here between points. And this one, we went up, we went down just slightly, and then we came back up again. So this one is in fact close enough to treat as an approximately normal population. Example 2. For each of the following histograms, determine whether it is reasonable to treat the sample as coming from an approximately normal population. Well, once again, I'm going to imagine my normal curve sketched around my data here, and this one looks like a really, really good fit around my normal curve, or underneath my normal curve. So I would say that yes, we could probably treat this as a normal population. When I go to look at this one over here, I'm sketching my normal curve over the top of it. You'll notice that whereas the graph A, we've got one peak in here and everything kind of goes downhill to the left of it and downhill to the right of it. Over here in graph B, we're increasing. We go down slightly, but remember that's okay as long as we go back up slightly. But this one goes up a whole lot and comes back down a whole lot, and then goes back up a whole lot, and comes back down a whole lot, and goes back up a whole lot, and comes back down just briefly, and then goes back up before coming back down again. So I would say that no, this is not going to be data that we would like to treat as a normal population. For example 3, we've got the following stem and leaf plot that represents a sample from a population. Is it reasonable to assume that this population is approximately normal? Now what we want to do is we want to imagine that this stem and leaf plot has been turned on its side, and our normal curve we would draw in this direction right here. So we would expect it, if the population or the data were normal, we would expect it to be doing something along this line right here. And what we can see based on this stem and leaf plot is that my curve actually does something like this. And so this time we would say definitely not. No, don't treat this sample as a normal population. Example 4. The following box plot represents a sample from a population. Is it reasonable to assume that this population is approximately normal? Well, this one's going to be a little bit harder to visualize because if we try and draw in the normal curve over the top of it, it's not really going to be too much of a help here. So we're going to have to more visualize this one. And what we're looking for is we're looking at the length of the whiskers. We want them to be about the same size, and these appear to be. And then we're going to check the box. And what we're looking for in the box is we want the inside of the box here to be about the same size as this one over here. Now I know that the left side of the box is in fact wider than the right side of the box, but I mean it's, you know, it's fairly close, and the fact that the whiskers are out here and they're pretty much the same size kind of balances things out a little bit. And the other thing we're trying to check out is we want to see the median right here. Is it really in the middle of the data? And it looks like it's pretty close to being in the middle of the data. So with all of these going for us, I would say that yes, we can treat this as coming from an approximately normal population. Example 5, is it reasonable to treat the sample in the following normal quantile plot as coming from an approximately normal population? What we're looking for here is all of the points that are plotted, do they fall pretty close to a straight line, or does it have any sort of curvature going on? Now if we look at graph A, these points right here seem to be hugging very, very close to this straight line. And while they're not in a perfectly straight line, they do suggest a straight line. And we could imagine one in there if the line were not already drawn in there for us. And so this one we could say that yes, because the data points fall very, very close to a straight line or to falling on a straight line, we can treat this sample as coming from an approximately normal population. Now when we look at B, we look at the points up here, these fall really, really close to the line, and even these are fairly close to the line. But when we look down here at the bottom part of the graph, we've got some on the left side of the straight line, then we've got it dipping down here below this line, and then it's coming back up here above the straight line again. And you'll notice that this particular graph seems to have a little bit of a curvature going right here, and it seems to suggest more an exponential type curve than it does a straight line. And so because of this curvature here, because we can see the curve, we would say no, we don't want to treat this sample as coming from an approximately normal population.